Okay, so today we're looking at the first part of our graphing, which looks at two different types of functions. So we have here two, they're both exponentials, but the first one is 2 to the power of x, and the second one is 1/2 to the power of x. So really, the similarities between them are they're both exponentials. Well, there is a 2 in both of them, but in this case, my base, they're different. The base is 2 and the base is 1/2 in this one. And then what we won't see until we graph it is that they're both going to share some other properties as well. So it's easier if we just go to the graph. If we look at this as x and y, for f at x is 2 to the x, and we do 3, 2, 1, 0, -1, -2, -3. When we do this, we have 2 to the power of 3, which is 8, 2 to the power of 2, which is 4, 2 to the power of 1, which is 2, and 2 to the power of 0, which is 1. 2 to the -1 makes it 1 over 2. 2 to the -2 makes it 1 over 2 squared, which is 1 over 4. And 2 to the -3 would make that 1 over 2 cubed, which is 1 over 8. So if we graph that, what it looks like, and if we kept going, we'd actually get a fraction that just keeps getting smaller and smaller and smaller. So we actually never touch the x-axis here. So we know we cross at 0, 1, and what it does is it just keeps going, and then it's just going to grow really quickly. Now we could have done that perfectly where it's 0, 2, or sorry, 1, 2, and then this should be, so if I do this a little bit better, if I do it a little bit better here, I have 1, 2, 2, 4, and 3, 8. So it's going to come through these points right here like that. So this is a growth model because it's we read left to right, and going from left to right is growing. One thing we have here that we haven't seen in a while is the asymptote. At y is equal to 0. It has a y-intercept of 0, 1, and our domain is everything again. But our range is everything as long as it's greater than 0. Okay? So if we look at g of x is 1/2 x, using our same x values, well, they're just completely flipped, because 1/2 to the -3, we flip that fraction, and we get 2 to the 3, which is 8. We're going to get 4 here, 2 here, 1, and then this is 1/2, 1/4, 1/8. So in this case, what ends up happening is, and then across here again, that doesn't bounce that much, my hand just moved, but this model is actually called the decay model, because from left to right, it's going down further. So that's the big difference we're going to see here on how it looks for now. So if we see a fraction, it's going to be this decay model. If we see a whole number, it's going to be a growth model. And if we really wanted to see something differently, here if we had here h of x is equal to 5 to the x, well, using these same things, you'd have 125, 25, 5, 1, and then our fractional pieces. So this is going to be very, very similar. But then what's going to happen here is as soon as we go to 1, it's at 5, which is here, and then 25. So it's actually going to grow even steeper. So if we look here, the bigger the whole number, the steeper it's going to be. The other thing we're going to notice here, so we haven't done this in a while. If we look at, I'm going to give you an example of y is equal to 3x. And if we have our x and y again, like our linear here, we had, let's say 0, 1, 2, 3, 4. Well, that would be 0, 3, 6, 9, 12. And one thing that we haven't done probably since grade 9 and 10 is we look at our differences, the first differences for them. So when it's linear, the first differences are all going to be the same. If we look at our very basic quadratic, which we know is 0, 1, 2, 3, 4, and that would be 0, 1, 4, 9, 16. When we do our first differences, we should notice here that we get 1, 3, 5, 7. They're not the same, but when we do our second differences, we get 2, 2, 2. So when we work those out, we get that if it's quadratic, it'll be our second differences are the same. If it's linear, our first differences are the same. When we get to grade 12 and we see a cubic, the third differences will be the same. But what doesn't work nicely is when you have this exponential, and we have 1, 2, 3, 4, and this would have been 1, 2, 4, 8, 16. Working out my first difference, 1, 2, 4, 8. Working out my second difference, 1, 2, 4, and if we had more numbers, it'd be 8 again. So notice how we're repeating this pattern over and over and over again. It's not really helping us. So what we do is we actually do something called the ratio. And we go back to our original numbers, and our ratio would be 2 divided by 1, 4 divided by 2, 8 divided by 4, and 16 divided by 8. And all these give us 2, which gives us that they're exponential. So if you work out your differences, and for now we only have to do first and second differences, and you're not noticing that they're working out nicely, then go straight to the ratio and see if they give you the same number. And if they are, then we know for sure it's exponential.